Welcome to our journey through Newton's laws of motion. Sir Isaac Newton introduced three fundamental principles that describe how objects move. First, we have the law of inertia. This states that an object at rest remains at rest, and an object in motion continues moving at a constant speed in a straight line unless acted upon by an external force. Picture a soccer ball sitting still until someone kicks it. Next, we explore the law of acceleration. This law reveals that the acceleration of an object depends on the net force acting upon it and its mass. In simpler terms, the more force you apply to an object, the more it accelerates. For instance, pushing a car requires more force than pushing a bicycle. Lastly, we discuss the law of action and reaction. It tells us that for every action, there is an equal and opposite reaction. When you jump off a small boat, you push the boat backward while moving forward. By understanding these laws, we can better comprehend everyday phenomena, like why seat belts are crucial in cars. Newton's insights continue to shape our world, connecting science with our daily lives.
In the advanced Kavetsky model, propulsion energy utilized for thrust is expelled through the exhaust, allowing the ship to gain momentum and speed, but not mass. This process does not warp spacetime significantly. Quantum physics aligns with established physics principles, demonstrating that a rocket accelerating by expelling reaction mass does not bend spacetime merely because it generates thrust. Instead, quantum physics conceptualizes propulsion as a momentum exchange with a spacefield medium, permitting acceleration without the distortion of spacetime. This distinction sets the model apart from traditional warp drive theories, such as those based on Alcubierre metrics, while maintaining coherent logic. A compelling summary from the paper articulates this concept elegantly. In quantum physics, propulsion energy is expended as thrust and carried away in exhaust, producing ship acceleration without inducing spacetime curvature. Speed arises from momentum exchange with the spacefield, not from warping the metric. This innovative perspective essentially reverse engineers a variant of unified field theory. If we envision space as a grid comprised of particles like Higgs bosons that generate mass, then propulsion can be understood as the mechanical manipulation of that grid. This manipulation effectively reduces the resistance encountered in front of the vessel. By understanding propulsion in this manner, we gain insight into the mechanics of acceleration without the need for conventional notions of spacetime manipulation. This clarity allows for new explorations into propulsion technology, firmly rooting the ideas in both theoretical physics and potential applications, leading to a more profound comprehension of how spacecraft might navigate the vastness of the universe.
In the realm of physics, the pursuit of faster-than-light travel often invites analogies that oversimplify complex theories. One such analogy is the notion of punching a hole in spacetime, an idea popularized in various discussions about superluminal motion. However, this imagery misrepresents the essence of general relativity. According to Einstein, spacetime curvature is not merely a consequence of speed, but rather a function of energy and mass density. Simply put, moving quickly through empty space does not warp spacetime, it is mass that exerts this influence. While a fast-moving ship may possess an increased relativistic energy when observed from a different frame of reference, it does not create a gravity well or manipulate spacetime as one might imagine. The analogy of tearing or puncturing spacetime, though visually compelling, falls short of scientific accuracy. Spacetime is not a fabric that can be ripped, rather, it is a complex structure that requires colossal forces, like those found in a galaxy, to alter significantly. As one approaches light speed, more energy is needed for acceleration, diverging towards infinity, but never allowing one to exceed this cosmic speed limit. The real breakthrough in our understanding lies in concepts such as those proposed by Miguel Alcubierre, which suggest manipulating spacetime itself, contracting in front and expanding behind a spacecraft. This approach retains the ship's local movement below light speed while allowing the spacetime around it to facilitate faster-than-light travel. Thus, acceleration is not merely about speed but involves intricate interactions with the spacetime metric. Quantum physics deviates further by proposing a model where propulsion energy acts independently of spacetime curvature. Here, propulsion is viewed as momentum exchange with a spacefield rather than traditional methods that warp spacetime. The energy expended through propulsion, transferred via exhaust, does not accumulate around the spacecraft to create notable curvature. Instead, it illustrates motion without significant alteration to the underlying spacetime metric. In this framework, local motion is decoupled from the geometry of spacetime. Expanding space can create superluminal effects in coordinate systems. Yet local observers will always adhere to light speed limits. The typical framework posits three components: local motion, metric expansion, and curvature, each operating independently, thus clarifying how propulsion can occur without altering the cosmic structures at play. By embracing these ideas, we can envision a theoretical pathway towards efficient space travel that aligns with the known laws of physics, while still exploring the boundaries of current understanding.
In the zero-energy universe hypothesis, gravity is the debt and matter is the cash. Together, the balance is exactly zero. This logic sets the stage for a new kind of propulsion. In the Kawecki model, thrust energy shreds in the exhaust. The ship gains momentum, not mass. This doesn't warp spacetime, it's acceleration via momentum exchange with the space-field medium. Propulsion interacts directly with the medium, staying distinct from Alcubierre-style warp drives. As the paper states, propulsion produces acceleration without inducing spacetime curvature. You've reverse-engineered a unified theory, manipulating the Higgs grid to zero out resistance. The future isn't about bending space, it's about understanding the grid.